Okay, so for the next subtopic is on partial derivative of an implicit function. Okay, so let's recap back. Okay, when we are dealing with explicit function, okay, it will be easy for us to differentiate. But how should we do if we have an implicit function? Okay, so first thing first, okay, you must know the definitions of explicit and implicit. Okay, for example, like this. Okay, so this is the example of explicit function where you can actually, okay, make it, or once you rearrange the terms, okay, you'll be able to make z as a subject when we talk about multi-variable function. Okay, if we recap back on whatever that you learn in differentiation, okay, for a single function, for example, if we have 3x squared minus xy plus 3y equal to 7, and then the question asks you to find dy dx. Okay, so first thing first, okay, let's take a look on this function. Okay, so from here, okay, we know that you'll be able to actually write, okay, in terms of y as a subject. Okay, so if we make an arrangement, so we're gonna have like this, right? 7 minus 3x squared. So if you make y as a subject, so you're gonna get 3 minus x equal to 7 minus 3x squared. So you're gonna have 7 minus 3x squared divided by 3 minus x. Okay, so now it's possible for you, okay, to differentiate for this one. Okay, so if you're using quotient rule, okay, so you're gonna get that dy dx is equal to 3x squared minus 18x plus 7 over 3 minus x squared. Okay, so so if you'll be able to write into this form, okay, so means that this is an explicit function. Okay, but okay, now, okay, I'll show you on how can you use implicit differentiation by using the same formula, the same function, so that we can compare the the what the we can compare with the answers. Okay, so from the original, if we use implicit differentiation, okay, implicit differentiation. Okay, so we have 3x squared minus xy plus 3y equal to 7. Okay, so if we would like to differentiate both sides, okay, implicitly respect to x now, so we're gonna have d dx 3x squared minus d dx xy plus d dx 3y equal to d dx 7 over here. Okay, so if you differentiate this one respect to x, okay, so you're gonna get 6x. Okay, so for this one, okay, so for this one, you're gonna get you use product rule, right? So you're gonna have minus x dy dx minus y, and for this part you're gonna get 3 dy dx equal to 0 over here. Okay, so by using the idea of implicit differentiation, okay, so the terms that have dy dx, so we make into one component over here, so we're gonna have dy dx equal to y minus 6x. Okay, so from here you're gonna get that dy dx is equal to y minus 6x over 3 minus x. Okay, so if we compare over here, it's different, right? But then, okay, so if you take a look on the right hand side, okay, all terms in terms of x, but our term here, we have y. So if you substitute y with the terms that you got just now, when you simplify, you're gonna get 7 minus 3x squared over 3 minus x, right? So definitely that if you substitute this term into this part, you're gonna get the same answer, which is 3x squared minus 18x plus 7 over 3 minus x squared. Okay, so that's how implicit differentiation works. Okay, so this part. Okay, so whenever we are dealing with multi-variable function, okay, you can use the same idea. Okay, you can use the same procedure, okay, while you applying implicit differentiation in order for you to find the partial derivative. Okay, but then, okay, we also introduce one theorem. Okay, we name it as theorem 4. Okay, an alternative on how can you find the partial derivative on an implicit function. Okay, so we introduce this theorem. Okay, so if you ask me, I would say that this theorem will be much more easier. Okay, less risk in terms of how should you differentiate both side implicitly. Okay, so I would suggest you to straight away use theorem 4 instead of using normal implicit differentiation, but it's depend on you. Okay, so how can we use theorem 4? Okay, so the idea of theorem 4, okay, you have to write in this form first. Okay, so means that from the given multivariable function, okay, so you're gonna rearrange the terms, okay, by making all the terms equal to 0, okay, and then you're gonna find the partial derivative respect to x, respect to y, and respect to z. Okay, so since we are dealing with a multivariable function, okay, so we're gonna have this formula. Okay, so let's take a look on example 9. Okay, so from example 9, okay, so we have, okay, so the first one, we have xy squared, okay, plus zy equal to negative x sine y to the power of 3 plus 2z. Okay, so this is the original function. Okay, so please bear in mind that the first step should be written like this. Function of x, y, and z is equal to 0. Okay, so normally, okay, all the terms on this side will be moved to this side. So we're going to have xy squared plus zy plus x sine y to the power of 3 plus 2z equal to 0. Okay, so this will be the big F over here. Okay, so if you would like to figure out del z del x, okay, so from this formula, okay, so you need to figure out negative fx over fz over here. Okay, so from this f, the big F, okay, so the big F over here is equal to xy squared plus zy plus x sine y to the power of 3 plus 2z, right? Okay, so let's differentiate respect to x. Okay, so you're going to have y squared plus sine y to the power of 3 plus 2z over here. Okay, so the next one is fz. Okay, so now we differentiate the big F respect to z. Okay, so we're going to have y plus, okay, 2x cos y to the power of 3 plus 2z over here. Okay, but this is not the end yet. Okay, so the answers that we are looking for, del z del x is equal to negative. Put it the big bracket unless you would like to expand it. Okay, so now the terms is y squared plus sine y to the power of 3 plus 2z over y plus 2x cos y to the power of 3 plus 2z over here. So this will be the final answer. Okay, so be careful with this negative. Okay, so normally the terms over here will have more than one term. Okay, so if you don't want to use the big bracket, make sure that you multiply with that negative to ensure that the final answer is correct. Okay, so now from the same function, okay, so let's figure out, okay, on how can you find del z del y. Okay, so now you need negative fy over fz. So we have figured out fz, right? Okay, so the next one is for you to figure out fy. Okay, so based on the big F that we figured out just now, so we have fy is equal to 2xy plus z plus x cos sorry, over here, once you differentiate, so you're going to get 3xy squared cos y of 3 plus 2z over here. Okay, so from here we know that the z del y that we figure out, or we would like to figure out, is equal to 2xy plus z plus 3xy squared cos y of 3 plus 2z. Okay, divided by fz that we figure out just now is equal to y plus 2x cos y of 3 plus 2z. Okay, so you can actually see that by using the given theorem, okay, it will be easy for you to to find the partial derivative with respected variable. Okay, but you can actually use a normal implicit differentiation. Okay, so you can try by your own, okay, to solve for B and C. I did give you the answers over here that you can try by your own. Okay, so I did also provide, okay, the sample of previous test and final exam, okay, in this part that you can also try by your own. That's all for this video. Thank you.